All right, 8.3 technically is about polynomial division. So like I said, there's two places we're going to use synthetic division in college algebra. So the first thing we'll use it for, we'll use synthetic division to find function values. So the big thing about using synthetic division to find function values, we got what we call a remainder theorem. And y'all, the remainder theorem just tells us that the remainder from doing synthetic division is equal to the function value for that particular value. So for that particular value being evaluated. So if I had a polynomial and I wanted to find f of 4, when I use 4 in synthetic division, that remainder that's left is equal to that function value if I had to put that number into the actual polynomial, okay? So we'll do a few examples doing this, and then we'll look at the other situation where we're going to use synthetic division. And y'all, this really just rides on that remainder theorem, okay? And remember, the remainder is what I had in the little boxed area at the end, okay? So we're going to use synthetic division to find the function values. So they're giving us f of x equals x to the third minus 13x squared plus 52x minus 60. They want us to find f of 2, f of a negative 5, and f of 6. Now, we'll say this. We're finding 3 values, so we're going to do synthetic division 3 times on this problem, okay? But what's good about it, we're using the same coefficients every time. So I'm going to start with f of 2. So y'all remember, 2 is what we call the first C. C is the value being evaluated. So my first number is 2. It matches what the function value is. Now we're going to write out our coefficients. So there's no missing terms. So I got a 1 for the x3, negative 13 for the x squared, 52 for the x term, and then negative 60. Now remember, leave a little space and then come across with your line. And then under the negative 60, I'm going to box that. This will be our remainder, which means it'll be our function value for finding f of 2, okay? All right, so let's knock out f of 2 real quick. So y'all remember, the first number, you always bring the first number down below the line. And then we're just going to start multiplying, adding, and repeating until we get done. So any number below the line gets multiplied by our C and put into the next column. So 1 times 2 is 2. So we're going to put the 2 into the next column. Then we're going to add that column. Negative 13 and 2 give me a negative 11. No, then we're going to repeat the process. Negative 11 times 2 is negative 22. Add the column. 52 and negative 22 give you 30. And then multiply by 2 again and get the last column. So 30 times 2 is 60. And negative 60 and 60 give me 0. So y'all, that means f of 2 equals 0. Then they want me to find f of negative 5. So I'm going to bring down my negative 5. That's my next C I'm using. My coefficients are still the same. So 1, negative 13, 52, and negative 60. All right, I'm going to draw my line and box under the negative 60 again. All right, y'all, so let's see what negative 5 has as a function value. So y'all, once again, bring the 1 down, and then we're going to start multiplying and adding. 1 times negative 5 is negative 5. Negative 13 plus negative 5 is negative 18. Negative 18 times a negative 5 is a positive 90. So then we got what? 90 plus 52 is 142. And then we got 142 times negative 5, which gives me a negative 710. And y'all add negative 710 and negative 60, I get a negative 770. So that means if we put a negative 5 into this polynomial, it will equal a negative 770. All right, y'all, so we said f of negative 5 equals a negative 770. So then we got one more, f of 6. So we bring down 6 as our next C. We write our coefficients, 1, negative 13, 52, and negative 60. All right, y'all, so let's see. We know now we bring the first number down below the line. And then we're just going to start multiplying and adding. So 1 times 6 is 6. Negative 13 plus 6 is a negative 7. Negative 7 times 6 is negative 42. All right, y'all, 50 and negative 42 give me 10. And then 10 times 6 is 60. And y'all look at that, negative 60 and 60 gives me 0. So that means if I put a 6 into this, it would equal 0. So we have f of 6 equal to or 0. So y'all, that's the trick on finding function values. Write out your coefficients, the number you're wanting to evaluate, that becomes your C technically, and then you run through synthetic division until you get to that remainder, okay? So what is the second reason I would use synthetic division in college algebra? So we use synthetic division to determine if a number is a 0 of a function. So I can use synthetic division to determine if a number is a zero of a function. So here's the thing. If a number is a zero, then the remainder from doing synthetic division must be zero. Okay, so if I run through synthetic division and I get a zero like I did here, then that means that that number is actually a zero of that function. So 2 would be a zero of this function, and also 6 would have been a zero of that function because they both had zero remainders here. Now the -5, it would not be a zero of the function because its remainder was a -770. So they'll give you a polynomial. They'll give you one or two numbers to check. We're looking for zero remainders, okay? I also want to flip my page and we'll start doing some examples to determine if a number is a zero, okay? So synthetic division, I always liked it. It's not too bad once you get used to the pattern on these, okay? So using synthetic division, determine whether the numbers are zeros of the polynomial. Okay, so they give me -1, comma 1. And then a semicolon letting me know now that my polynomial is h of x equals x to the fourth plus 2x third plus 2x squared minus 6x minus 7. So these are the two numbers they want me to check, and this is my actual polynomial. So these answers will be yes, no, no, yes, 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 or no, no. Okay, so we'll check each one. So we'll start with -1. We'll write our coefficients. Notice nothing's missing. X4, X3, X2, X and our number. So nothing's missing. So let's write down the numbers. We got a 1 for the X4, 2 for the X cubed, 2 for the X squared, -6 for the X, and then our -7. All right, then we're going to box up under that -7. So all we're looking for is a zero to put yes, okay? Any other answer, we're going to put no. All right, y'all, so here comes the fun part. Bring that first number down. And then we're going to multiply and add until we get done. So 1 times -1 is -1. 2 and -1 give me 1. 1 times -1 is -1. 2 plus -1 is 1. 1 times -1 is -1. -6 plus -1 is -7. And y'all look at that. -7 times -1 is a +7. When I add -7 and 7, I get a remainder of 0. So this first one would be yes. So now we check 1. And y'all, we got the same coefficients, 1, 2, 2, -6, -7. All right, so I'm going to give y'all about a few minutes, and I want one of y'all to tell me, is 1 a 0 of this polynomial or not? If it's yes, then that means you got me a 0 there. If it's no, tell me what your remainder was if you didn't get a 0, okay? And y'all, I'll let y'all run that for a little bit. I'm gonna pull my chat up so I can see. This way I can sort of tell if y'all are getting an idea about this here synthetic division. All right, y'all, I'm starting to get some answers in. I'm getting a no. We're getting -8s. No, we're getting -12s. So apparently we ain't getting zeros on that for sure, right? So y'all were saying no. So let's see who's right. Am I going to get a -8 there or a -12? We'll see. All right, y'all. So y'all brought that 1 down. 1 times 1 was 1. Then y'all did 2 plus 1 was 3. 3 times 1 was 3. 2 plus 3 gave me 5. All right, y'all, 5 times 1 is 5. -6 and 5 gave me -1. And then let's see, -1 times 1 is a -1. Uh-oh, looks like I am going to get a -8. So Jackson, let's see. I bet you got your mistake right around here somewhere. And that threw your numbers off just a little bit. But y'all, good job. This is definitely a no. All right, so we'll do one more in this section and then we'll move into our 8.4. So y'all, we're going to do the same thing. We're going to use synthetic division to determine whether a -3/2 is a 0 of, and y'all, we got f of x equals x to the third plus 5/2 x squared plus 13/2 x plus 15/2. So they're throwing fraction at you. But y'all, the one thing I would be happy about on this one is all the fractions got a 2 on the bottom, okay? So they already got a common denominator sitting down there. So our C is now a -3/2. Nothing's missing, so my coefficients are 1, 5/2, 13/2, and 15/2. So all of them were positive. Now I'm going to leave a little more space because I got fractions. And then I'm going to box under this. Y'all, I'm still looking for a 0 remainder to put yes. Anything else, I'm going to put no. All right, y'all, so let's spin this one around. Let's bring that 1 down. So 1 times -3/2 is a -3/2. So y'all, what I'm wondering, what does 5/2 minus 3/2, what's that give me? Good job. That is a 1 because 5 minus 3 would give me 2 over 2. So y'all remember 5 halves minus 3 halves. 5 minus 3 on top is 2 over that common denominator, which was a 2 on the bottom. And that equaled 1 on that. And good job. All right, so here we go. 1 times negative 3 halves is a negative 3 halves. So what I'm wondering now, what does 13 halves and a negative 3 halves give me? Oh, Nat, you're doing pretty quick. Good job. Because 13 minus 3 would be 10 over 2, and 10 over 2 reduces to a 5. So y'all remember, on fractions, you do all the stuff on top, and you always put it over your common denominator. All right, good job. So now what do we got? 5 times negative 3 halves. That equals a negative 15 halves. So y'all, what I did when I multiplied that, you treat the 5 like it's got a 1 under it, and you just multiply straight across with fractions. So that 2 times 1. So you get the negative 15 over 2. And good job, Nat, because those give me a big 0, which means yes, negative 3 halves is a 0 of that function. So y'all, you'll find out synthetic division ain't bad once you get used to the multiplying and adding, multiplying and adding, multiplying and adding until you get to them remainders, okay? So that's pretty much 8-3. There's only 5 questions in that, and we did 3 of them. So the other 2 will be similar to these ones we just did. 8.4 is going to go another direction with us. So y'all let me get my pad ready. All righty, so 8.4. This is theorems about zeros. And then other things in this section, okay? The theorems we'll see a little bit later in this section. But in 8.4, they start out, they want us to find polynomials given the solutions. So we're going to be finding polynomials given the, and we'll technically call these zeros. But remember, zeros are the solutions, okay? So the best way to do this is to actually work a problem out, because what we're doing, we're working in reverse of what we did when we found zeros. So y'all watch this. Find a polynomial of degree 3. Now, when they say this, find a polynomial of degree 3, they mean that your biggest exponent of your polynomial better be a 3, okay? We also know this. If it's a degree 3 polynomial, then they got to give me 3 zeros, okay? Because the degree of the polynomial tells you how many zeros you got, okay? And then it says, with real coefficients that has the given zeros. All right, so like I said, since this is a degree 3, they got to give me 3 zeros. They're giving me -2, 3, and -7. So they're giving me the solutions or zeros. We're going to work in reverse and come up with what polynomial those came from, okay? So if these are zeros, that means x equals -2, x will equal 3, or x can equal -7. So y'all, the first step I would do to this, I need to get a 0 on the right side of each equation. Because remember, I'm working in reverse. So if I'm going to get a 0 on the right side of each of these equations, I'm going to add 2 to the first one. And y'all, I get x plus 2 equals 0. So I'm basically moving these numbers to the other side and changing their sign, okay? So the 3, I'll subtract 3. I get x minus 3 equals 0. And then for the -7, to make that a 0 over there, we're going to add 7 to both sides. So now, since all 3 of these equations are equal to 0, I can multiply all 3 of these together and still make it equal to 0. So we're going to come in and do x plus 2 times x minus 3 times x plus 7. All of those together have to equal 0. So write as a product equal to 0. Right, that's the 0 product rule. If this factor equals 0, then this whole thing is 0. And vice versa for each of those, okay? So y'all look here. I've got 3 things being multiplied. So what I'm going to do, I'm going to start with the last 2 things and I'm going to FOIL those. So I'm going to bring down to x plus 2. Now over here on the side, I'm going to figure out what is a x minus 3 times a x plus 7 equals. So I'm foiling 2 of these at a time. Now you can do the first 2, you can do the last 2, you could have foiled the first and the last. It don't matter what 2 you foil first, okay? So let me foil this real quick. X times x is x squared. X times 7 is 7x. -3 times x is -3x. -3 times 7 is -21. I'm going to combine like terms in the middle so that I get an x squared. 7 minus 3 leaves me 4x, and then minus my 21. So these 2 foiled into that. So let's put that here. X squared plus 4x minus 21. And all this is still technically equal to 0. So I still got to multiply because I got parentheses next to parentheses. So we're going to take this whole thing and we're still going to FOIL, but it's going to have a few more steps on it, right? You're going to have a little bit of more in that middle stuff. So instead of FOILing, I'm just going to say multiply all this. But it is still sort of FOIling, okay? This x, I'm going to distribute times all 3 of these. This 2, I'm going to distribute times all 3 of these. So y'all, here we go. X times x squared is a x to the 3rd. x times 4x is a 4x squared. X times negative 21 is a negative 21x. Now let's distribute 2. 2 times x squared is a 2x squared. 2 times 4x is an 8x. And then 2 times negative 21 is a negative 42. Woo, hopefully them mowers ain't too loud on y'all. They mowing outside there, it sounds like. Y'all, at this point, all we can do is add like terms. So the x to the third's coming down. Let's see, I got 4x's squared. I can add to the 2x squared. That'll give me 6x squared. This negative 21x will add to a positive 8x, giving me a negative 13x. And then at the end is my negative 42. And then all this equal to 0 technically. Now here's how MATLAB does the answer. So MATLAB will have this. F of x equals x to the third plus blank x squared minus 13x minus 42. So we know we done it right. We got all of our numbers matching. So y'all, all they wanted me to do with this whole problem was figure out what went into that box. So what's in front of the x squared term is a 6. But y'all, to get that answer, that 6, you have to do the whole thing and see what this whole polynomial equals, okay? So notice, you got a little bit of foiling to do when you try to find a polynomial. Now look here, they said degree 3. Well, y'all look at my degree right here. My highest exponent is a 3, okay? And also, a couple more of those real quick. So I'm about to see what y'all remember about y'all's pre-algebra stuff. So find a polynomial with zeros of, so y'all watch this one. My zeros are 2, 2i, and a negative 2i. So y'all, this one will be a little funner, right? Now, they didn't tell me what degree it would end up with, but y'all guess what? We got 1, 2, 3 zeros. So we better end up with an x to the third when we're done, okay? Hey y'all, so I know x equals 2, x equals 2i, and x equals negative 2i. So we got our 3 zeros. Y'all remember, I need a 0 on the right side, so I'm going to add and subtract to move everything over. So that's a positive 2, we're going to subtract 2. And I get x minus 2 equal to 0. The 2i, we're going to subtract 2i. We get x minus 2y equals 0. And then on the third one, we will add 2i. And I get x plus 2y equals 0. All right, so I got my three equations all equal to 0 now. So now I'm going to make a big product and put everybody in parentheses. So I got my x minus 2, x minus 2i, and then an x plus 2i. All of that equal to 0. So let me get my side work ready. Y'all, when I got imaginary stuff, and these are actually what you call conjugate pairs. X minus 2i, x plus 2i. Conjugate pairs look the same other than the adding and subtracting. So I want to show y'all what happens when you FOIL imaginary numbers. So y'all, I got x minus 2i times x plus 2i. Now here's the thing about conjugate pairs being multiplied with imaginary numbers. If they're conjugate pairs, then when you FOIL this, all the imaginary stuff will go away. Okay? So watch what I'm saying. So let's FOIL this out long way. X times x. Well, y'all, x times x is an x squared. Let's take this x times 2i. Well, x times 2i is a positive 2ix. All right, so now let's distribute that negative 2i. Negative 2i times x is a negative 2ix. And then, y'all, here we go. The negative 2i times a positive 2i is a negative 4i squared. So y'all watch the magic about to happen. What happens with the 2ix and the negative 2ix? Because y'all, you got like terms right there. Well, they're going to cancel. So the middle terms cancel. So y'all, here's another question. What does I squared equal? Oh, good job, Dad. I squared equals -1. And y'all, to verify that, watch this. We got a calculator. You see the blue I above the dot? If you hit the second button and the decimal, there's your I. I'm going to square that. And y'all look at that. I squared definitely equals -1. So what that means, wherever you see a I squared, you're going to replace that with a -1. So watch what happens. The x squared comes down. This -4i squared is really -4 times -1. So that makes that a +4. So all I squared does is it changes the sign of the number in front of it. Now, when you FOIL conjugate pairs of imaginary numbers, they always come out as an x squared plus that number, okay? All right, so notice, all the I stuff is gone though, y'all. So bring down this x minus 2 over here. Whoops. This stuff equals x squared plus 4 now. And all that equal to 0 still, okay? All righty. So that's why I start with imaginary stuff, so you can get rid of the I. And then look here. All we got to do now is FOIL that, 2 things times 2. So here we go. X times x squared is x to the third. X times 4 is 4x. Negative 2 times x squared is a negative 2x squared. And y'all finally, negative 2 times 4 is a negative 8. So y'all technically, I would do one more thing to that before I put it in as my answer. And y'all, what's one thing we would do? We're going to put this thing in order, right? It's out of order at the moment. So good job. We're going to arrange it, Jackson. So we're going to bring down our x to the third minus the 2x squared plus our 4x and then minus our 8. All right, y'all. So like I said, this chapter 8.4 has a lot of foiling when you first started, okay? So I've got to play with y'all on imaginary stuff. How about something like this one? Find the polynomial of lowest degree with zeros, square root of 5, negative square root of 5, and 4. So y'all look at that. They're breaking out radicals on us now. But that's no problem. First of all, we got 3 zeros. So once again, we will end up with an x to the third as our biggest exponent, okay? So we'll knock this one out and then we'll do our break. So we know that x equals square root of 5. X equals a negative square root of 5. And then x equals positive 4. Remember, the way you get these kind of zeros was doing the square root stuff, right? The plus or minus stuff. Same thing with the I. It was from doing square roots of negative numbers. All right, guess what? I'm going to add and subtract, get zeros on this. So I'm going to subtract square root of 5 on my first one. X minus square root of 5 equals 0. I'm going to add square root of 5 on the second. X plus square root of 5 equals 0. And then on the last one, I'm going to subtract 4 and get x minus 4 equal to 0. All right, just like up here, I had 3 equations. I'm going to write them as a product now because they're all equal to 0. So I got x minus square root of 5, x plus square root of 5, and then x minus 4 all equal to 0. So y'all, here's another thing on this one. These are conjugate pairs of the radicals. One's being subtracted, one's being added. So if I was going to start foiling on this one, I would start with the radicals. So let's play with that on the side. X minus square root of 5, x plus square root of 5. Now remember, when you multiply radicals times numbers, it's outside times outside, inside times inside, okay? Now these are conjugate pairs. So the nice thing about multiplying conjugate pairs of radicals is that the radicals are going to disappear. Well, that looks good over there, girl. So good job. So let's see what happened. X times X is X squared. X times square root of 5 is the square root of 5x. Then the inside, negative square root of 5x. And then y'all, positive times negative is a negative square root. 5 times 5 is 25. So since this 5 was under, that 5 was under, I multiplied them, get 25. But y'all look here. What happens here? Well, those cancel again. Because they're like terms, except one's added and one's subtracted. So I'm going to bring down my x squared minus, well, what's the square root of 25? And that perfect. We got a 5 over there. So here's another property. A radical times itself gives you the number that was under the radical. Okay? All right, y'all. So all I know is these first two equal x squared minus 5. Then bring down that x minus 4. Now, y'all look here. Imaginary stuff always ends up positive. Radicals always end up negative, okay? All right, y'all. So final step, let's FOIL this out. X squared times x is an x to the third. X squared times negative 4 is a negative 4x squared. Negative 5 times x is a negative 5x. And then negative 5 times negative 4 is a positive 20. And technically, all equal to 0. So all MATLAB will do, now this one actually had multiple choice, but they put them in function notation, but it looks just like our answer, okay? So we set them to 0 to sort of solve them. And then after that, since we now have our polynomial, they're putting it in function notation on those, okay? All righty, so that gets us through the first 3 in 8-4. They deal with finding a polynomial if you know the zeros, okay? So y'all, when we come back, we're going to learn more stuff about zeros, and then we'll continue on, okay? So, it's almost 10:50 on my watch here. So y'all, let's take a break till 11 o'clock. At 11, we'll come back in and finish out some of this 8.4. All right, buddy, showing 11 o'clock. So we're going to continue in 8-4, okay? So let me get us recording again. All righty, so here's some theorems about zeros. So two little theorems about zeros, okay? So imaginary zeros always come in conjugate pairs. So imaginary zeros always come in conjugate pairs. So that means if 3i is a zero, then negative 3i is also a zero. Okay. If they look like complex numbers, if 7 plus 4i is a zero, then 7 minus 4i is also a zero. So if they give me a zero of something like 7 plus 4i, then I automatically know that 7 minus 4i is also a zero, okay? Because remember, you get the 4i and the negative 4i stuff from doing the square root. And the square root always has a plus and minus on it. So imaginary zeros always come in conjugate pairs. Well, y'all, that means guess what? Radical zeros always come in conjugate pairs. So that's why a while ago when we was doing that foiling, if they gave me square root of 5, they had to give me square root of negative square root of 5 as the other zero, okay? They always come in conjugate pairs. So that means if a square root of 5 is a zero, then a negative square root of 5 is also a zero. And these can be written as a real number and a radical. So if you had something like 2 minus square root of, oh, what I want here, 3. If 2 minus square root of 3 is a zero, then 2 plus the square root of 3 is also a zero. Okay, so imaginary zeros in conjugate pairs. Radical zeros come in conjugate pairs. So y'all, let's see how y'all do on this question I'm about to ask us. Suppose a polynomial of degree 4. So degree 4 means it's got 4 zeros altogether, okay? So suppose a polynomial of degree 4 has the following given numbers as sum as zeros. So suppose a polynomial of degree 4 has the given numbers as zeros. They want us to find the other zero. So y'all, the zeros they're giving us are -1, square root of 2, and 8/3. So the question is, what is the other zero? So the other zero is blank. So y'all, what would my under zero be? They're giving me 3. But based on these 2 theorems, what's my under zero? Oh, I didn't think about it. This might be hard to try to punch on that keyboard, I guess. But let me show you on this one. I'm looking at that square root of 2. Based on this theorem, they told me if one square root was a 0, then its negative is a 0. So since they gave me a square root of 2, that means my under 0 has to be a negative square root of 2. Okay, so these questions are based off of this stuff right here, okay? So let me see what y'all do on this one. So degree 4 polynomial has the given numbers as zeros. They want to find the under zeros. So what are they giving us? They're giving us I and 3 minus square root of 5. Now this is just 2 numbers, I and then a 3 minus square root of 5. So the under zeros are blank. Now guess what? I got a degree 4 polynomial. That means I need 4 zeros altogether. Y'all, they gave me 2 of them. So any guesses on what these under zeros might be? All right, so what am I getting? I'm getting a negative I because I is a conjugate with a negative I. Good job. And then what do you got? 3 plus square root of 5. Good job. Because the radical parts are conjugates, so that would give me a 3 plus square root of 5. Okay, y'all. So and then 6 was doing the same thing. They're going to give you 2. You find those 2 other zeros, okay? So this next problem is going to be like number 7. So based on everything we've done today, we're going to find polynomials again, okay? But y'all look at this. They want us to find a polynomial of lowest degree that has the given numbers as some of its zeros. All righty, y'all. So the numbers they're giving me are a negative 3i and a 4. Now we're finding a polynomial, so that means we're going to be doing some foiling and stuff. So y'all, here's a question. I don't have all my zeros. So what might be missing from what they're giving me? Um, well, we got to x equals All right, so y'all are getting my equations right, but y'all, I'm missing a zero. I've only got two. I got negative 3i and I got 4. What's missing based on what we know that we just went through? What else has to be a zero? All right, y'all think the conjugate pairs? 3i, good job. So y'all, 3i must also be a zero. If they give you an imaginary, you got to bring that conjugate in also. So that means x will equal negative 3i, x equals 3i, and x equals 4. I'm just putting my imaginary stuff together so when I foil, it'll be a little easier, okay? All right, y'all. So now that we know the missing zero, let's get everything on one side equal to 0. So I'm going to add 3i. So x plus 3i equals 0. Minus 3i from the second. So x minus 3i equals 0. And then on the last one, we'll subtract 4. And we get x minus 4 equals 0. So yeah, the most important part on this is make sure you get that under 0, okay? All right. Everything's going in parentheses. And y'all, guess what? I'm going to start by foiling the first two. So on the side, I'm going to do x plus 3i times x minus 3i. So that'll give me an x squared minus 3ix plus 3ix, and then minus 9i squared. So y'all, once again, the middles cancel. I squared equaled -1, we said. So replace I squared with -1 so that we end up with an x squared. And remember, all that -1's doing is making that -9i squared into a positive 9. So we know what the first two equals because we just FOILed those. So I get a x squared plus 9 times my x minus 4, all equal to 0. So guess what? The last step, FOIL this now. So y'all, here we go. X squared times x is an x to the third. So my highest exponent matches how many zeros I had. And then x squared minus 4 is a -4x squared. 9 times x is 9x. 9 times -4 is -36. All right, so my polynomial will be f of x equals x to the third minus 4x squared plus 9x minus 36. Okay, y'all, so that's really the trick on these. Is to remember that imaginary and radical come in conjugate pairs. So they had another one like this, number 7 for number 8 that I'm about to show you. So this example will be like number 8. So y'all, same thing. Find the polynomial lowest degree. Um, that has the given numbers. As some of its zeros. All right, so what are they giving me? They're giving me a square root of 2 and 4i. So, am I missing any zeros? And if I am, what are those zeros, y'all? So negative square root of 2, good job. That's going to be one of them. And what else? Negative 4i, good job. So a negative square root of 2 and a negative 4i must also be zeros. Which means when we're done, we're going to end up with a degree 4 because we got 4 zeros. Now I'm going to set them together so when it's multiplying, they're easier. So I'm going to do x equals square root of 2, x equals negative square root of 2, x equals 4i, and x equals a negative 4i. All right, add and subtract, get zeros on the right side. So I'm going to subtract square root of 2 on my first one. X minus square root of 2 will equal 0. Add square root of 2 to the second. So I get x plus square root of 2 equals 0. So I got my conjugate pairs here. And then here, subtract 4i. And then y'all finally add 4i. Alrighty, so now we're going to throw them in parentheses and start foiling. And y'all, what's nice on these? I'm going to work these two and work these two at the same time. I'm going to foil these and I'm going to foil those. Okay. Alrighty, so let's work that on the side here. So radicals first. X minus square root of 2, x plus square root of 2. So you're going to watch this. I'm going to show you how to shortcut these. Because this middle and outside stuff, they're going to cancel every time. So when you foil conjugate pairs, we can do the quick way. We can do x times x, which is x squared. And then we can do the negative square root of 2 times the square root of 2 would give me a negative square root of 4. But y'all, we know the square root of 4 is 2. So that ends up as the x squared minus 2. So you can shortcut the first two times themselves and the last two. So that the first two gave me x squared minus 2. Now, I'm going to FOIL the last two. They're conjugate pairs. Their inners and outers are always going to cancel. So we can shortcut this. X times x is x squared. Negative 4i times 4i is a negative 16i squared. Which y'all remember, I squared equals negative 1. So this becomes x squared. Negative times negative makes that a positive 16. So you got to remember, imaginary numbers always are positive. Radicals will always end up negative, okay? So I'm going to put that in here, x squared plus 16. So my last step is to take these two things and FOIL. So look at this, on a degree 4, I had to FOIL once here, and once here, okay? So a lot of foiling if you got bigger degrees. All right, y'all, so let's see what we get. X squared times x squared is x to the 4th. X squared times 16 is 16x squared. Now notice, I'm not shortcutting these ones like I did the conjugates because this stuff don't cancel out quite like those did, okay? All right, y'all, here we go. Negative 2 times x squared is a negative 2x squared. And then negative 2 times 16 is a negative 32. Oh, look, y'all, this one does have like terms. So bring down your x4. 16 and negative 2 give me 14x squared. And then at the end is my minus 32. So the only other thing you're going to do is they'll put this in as f of x equals our polynomial right there. So the trick on this question, you're doing the same thing you did on question 1, 2, and 3. The only difference is they might not be giving you all the zeros, and you got to remember what the other zeros are when you're making a polynomial, okay? All right, so we start changing the tune around number 9 here. So check this out. It says the polynomial has the given zero. They want us to find the other zeros. All right, y'all, so they're giving us f of x equals x to the 3rd plus 6x squared minus 7x minus 42. And y'all, they're giving me a semicolon. The zero they're giving me is negative 6. So here's what we're going to do to this one. We're going to use synthetic division. We're going to divide out this negative 6, and then I'm going to show you what we call the quotient is what's under the bar next to that remainder. We will use that quotient that we get from synthetic division to find the last two zeros. Okay, so if you start with a x to the 3rd, you do synthetic division once, and then to find the last two zeros, we're going to use the quadratic formula or the square root or something like that. Now, if I started with an x to the 4, I would have to do synthetic division twice before I could do the quadratic stuff, okay? So watch this. We're going to divide out the negative 6 first. Now, our coefficients, x3, x2, x in our number. So we got all the coefficients. So we got a 1, 6, negative 7, and a negative 42. So this is how you find the other zeros when your zeros are not conjugate pairs. And you just can't name them off, okay? So this is how we find our other zeros. We divide out the first zero that we know of. Now, here's a question for y'all. If negative 6 is a zero of this polynomial, what will my remainder be? So that's on y'all. What remainder do I need to get if that's an actual zero of that polynomial? So Macy, what you got? 0, perfect. So we know we got to get a zero remainder since they told us that was the zero of this polynomial, okay? So here we go, y'all. Remember the first number we bring straight down. Then we're going to multiply 1 times -6. That gives us -6. -6 and 6 give me 0. 0 times -6 is 0. -7 plus 0 is -7. And y'all look at that. -7 times -6 is 42. -42 and 42 equal 0. So we got a 0 remainder. So y'all, these three numbers are technically the quotient, and they give me the coefficients of the new polynomial that starts out 1 degree less than the original. Okay? So these are the these are the coefficients. So let's write that down. Coefficients of the new polynomial, and it starts 1 degree less than the polynomial given. So what that means, if this was an x to the third, that means that this starts as 1x squared. So we got 1x squared plus 0 x's. So I don't have to write that because that's 0 x's minus 7. So this is the x squared term, the x term, and the number. But since I had a 0 here, I didn't have to write that x. So y'all, I'm going to set this equal to 0, and we can solve this really quick by doing square roots to it, okay? So if you got an x squared in a number, I'm just going to solve by taking square roots. So add 7 to both sides. We get x squared equals 7. Now take a square root of both sides. So the square root of x squared is x. That's going to equal, now we're taking the square root of a number, so we need our plus or minus. And y'all look at that. We can't simplify that square root of 7. So that's just going to be a plus or minus square root of 7. Because remember, radicals come in conjugate pairs. So for this one, they're going to say the other zeros are blank. We don't put in the -6. They gave us that one. All we got to do is put in our square root of 7 and our negative square root of 7. Now listen, MATLAB will let you use the plus or minus, okay? So y'all with me? Synthetic division is how I'm going to get my other zeros when they give me one, okay? All right, y'all, so let's do number 10. So I'm going to see how y'all do on this number 10. I'm going to let y'all sort of guide me on this one. So this would be like number 10. So for the polynomial, um, 1 0 is given. Find the remaining zeros. All right, y'all, so let's see. My polynomial is f of x equals x to the 4th plus 40x squared minus 441. Now, they are telling me 7i is a 0. All right, so that's the x to the 4. When we're done, we'll have 4 zeros. They gave me one of the zeros, so we're looking for 3 more. So y'all, let's start out with the one they're giving us. They're giving us 7i. So here's where you got to watch out on this one. Notice, we don't have an x3 term here. Notice, we don't have an x term here. So I'm going to use zeros for placeholders on the missing terms. So the x4 is a 1. There's no x3s, so that's a 0. The x squared is a 40. There's no x, that's a 0. And then the number at the end is a negative 441. So here's a little trick. Whatever the degree is, if you add 1 to the degree, that tells you how many numbers you need here. So 4 plus 1 means I needed 5 numbers, okay? Well, y'all, if 7i is a 0, we better get a 0 remainder when we do this. So here we go. Let's bring down that 1. I is 7i. 0 plus 7i is 7i. Now here's the question. What is a 7i times a 7i equal? Let's see what would y'all put for that? 7i times 7i. All right, good job. That's a negative 49. Because remember, that would be 49i squared, but the I squared makes that a negative 49. 40 and negative 49 give me negative 9. Negative 9 times 7i is a negative 63i. Well, 0 plus negative 63i is a negative 63i. So y'all, what is this equal? Negative 63i times 7i. So multiply that out and see what y'all get. So we got a negative 63i times 7i. And we know what it better equal, right? Exactly. If that's a negative 441, we better get a positive 441 out of that. Because we know the remainder has to be 0. So y'all, here's the thing. I still got 4 numbers. So since this was an x4, this would now be 1x cubed, 7ix squared, minus 9x, minus 63i. I still got 4 numbers, so I'm going to use those 4 numbers, and we're going to do synthetic division again. All right, so you use these 4 numbers and do synthetic division again. But y'all, I need another number to check. All they gave me was 7i. I can't get the last 2 until I get this down to 3 numbers. So what is another number I can check with this polynomial? Oh, Nat, look at you go, girl. Because we know if 7i is a 0, then we better check a negative 7i. So the first of my other zeros is going to be that negative 7i. So y'all, let's see if we get a 0 here. So we're going to bring the 1 down. 1 times negative 7i is negative 7i. Well, add them together, you get a big 0. And 0 times negative 7i is a big 0. Negative 9 plus 0 is negative 9. And y'all look at that. Negative 9 times negative 7i is a positive 63i. When you add them together, you get a 0 answer. So the first of our other zeros is negative 7i. Now we're down to three numbers. We got an x squared plus 0x minus 9. All this is equal to 0. So we're going to get our last two zeros by doing the square root. So once again, I'm going to solve by taking square roots. All right, so I would add my 9 to both sides, get that x squared by itself. Take square roots of both sides. So square root of x squared gives me x. That's going to equal a plus or minus, and y'all square root of 9 is 3. So they're going to ask you for the other zeros are blank. Well, we don't put the 7i. They gave us that one, but we do need to put the negative 7i, and then the 3 and negative 3. Or you could do the negative 7i and then the plus or minus 3, okay? Just remember, that had a degree 4 on it, so you need 4 zeros altogether. If they gave you 1, you had to find 3, okay? So that's really sort of why they wanted y'all to learn that imaginary and radical stuff come in those conjugate pairs. So y'all, what do we do when they don't give me none of the zeros? So these will be like 11 and 12. So y'all watch this one. They want me to find the rational zeros and then the other zeros of the polynomial f of x equals x to the third minus 57x plus 56. So that was A. So this would be part A. For part B, they want me to factor into linear factors. So this means basically find all the zeros. Rational zeros are the zeros that are not radicals or are not imaginary. The other zeros are your imaginary and your radicals, okay? Everything else will be rational. Now, when they say factor into linear factors, they just wanted to put it in parentheses. Okay, so I'll show you how to do that. So first of all, I know that since that is a degree 3, I'm going to get 3 zeros. Now, here's the sad thing. They didn't give me no numbers to start at. So, you know what I would do to that? To help me find at least 1 zero, I'm going to graph it. Because if I can graph it, the zeros are equal to the x-intercepts of the graph, okay? So if we can at least find a place where it's crossing the x-axis, we got some of our zeros. So I'm going to go to my calculator and actually graph this function to help us find at least 1 zero, okay? So y'all, I'm going to go to y equals here. So my function was x to the third, so x exponent 3, arrow down, minus 57x plus 56. Now we just want to look at the graph and see if we can tell where this thing is crossing that x-axis at. Woo, y'all, I can almost get all 3 of these zeros. Look, it's crossing right here. It's crossing right here, and it's crossing on the right side. So technically, I can start with any one of these three numbers. So y'all, that looks like an easy number right there sitting at 1. Now, if I want to verify that, let's go to the table. Second graph to go to the table. Look at that. At 1, I got a 0 for the y. I can also tell you another one would be 7 because it's got a 0 for the y. And if I go to that negative side, the other one would be -8 because it had a 0 at y. So I'm just going to start with 1 on that. Although we know the 3 zeros because we're seeing the graph of all 3 of them. Okay. So I know 1 is a 0. So I'm going to start with 1. Now write my coefficients. Remember, I'm missing the x squared term on this one because 3 plus 1 means I need 4 numbers. Well, I've only got 3. So for the x squared, we need to add a 0. So we got a 1 for the x3, 0 x squared minus 57 for the x, and then 56 for my number. All right, y'all, if we're right, we better get a 0 there, okay? So here we go. We're going to bring the 1 down. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 57 and 1 is negative 56. And then negative 56 times 1 is negative 56. Add those together, you get a 0 remainder. So let's see what's left. Remember, this is now 1 degree less than an x3, so that means I got 1x squared plus 1x minus 56 has to equal 0. So y'all, I'm going to solve this one actually by factoring. Or you could do the quadratic formula, A, B, and C if you like that, okay? So y'all watch this. X squared is x and an x. My last number's negative, so one will be positive, one will be negative. So y'all, what factors of 56 will subtract to give me 1? And remember, you can do that calculator trick I showed you. Find factors of 56 on the calculator. You can go to y equals. And if I want factors of 56, I'm going to do 56 divided by x. Now, when you go to the table, let me get down to the numbers I need. So 0 is not a factor. So 1 and 56, 2 and 28, 4 and 14. Oh, and look at that, 7 and 8. So on that, you got it already there. Okay. So good job. The bigger number's positive like the middle. So 8, and then 7 would be negative. So y'all look, it's going to give us those other 2 answers we've seen. Remember, it crossed over at -8. We've seen that on the graph. And then it crossed over at the +7. We've seen that on the graph. So rational zeros, and they are blank. So we would put in our 1, -8, and 7. Okay. Now, like I said, if I would have had radical answers or imaginary, I'd have put which ones were rational, and then I'd have put the other zeros are blank, blank, blank. So I think 12 will do that. Now, linear factors. Is blank. All we do, we're going to put these in parentheses. If this 0 is a 1, then the factor will be x minus 1. If the 0 is a -8, then the factor would be a x plus 8. They just want y'all to realize that these factors are opposite in sign than the zeros. And then that last one would be what? X minus 7. Okay? So that's what they mean by linear factors. Taking your zeros and writing them as factors in those parentheses. Hey y'all, so we got one left, and that's the tricky one. I'm going to have to show y'all a little trick or two on that calculator, okay? All right, y'all, this one will be like your number 12. So the same answers. We're going to find the rational zeros and the other zeros. So find the rational zeros. And then the other zeros. Um, and that'd be A, remember A. So they're giving us f of x equals 5x to the third plus 7x squared plus 245x plus 343. And then B, factoring the linear factors. So pretty much the same thing. All right, so let's go. We got our coefficients. Nothing's missing this time. So we got a 5, 7, 245, and a 343. But once again, I don't have a number to try for my first zero. So guess what? We're going to graph it and we're going to try to find a zero, okay? We need at least one. Now, watch what happens on this one though. So let me show y'all on this one. All right, so let me put that in. I had 5x exponent 3, arrow down, plus 7x squared plus 245x plus 3, 4. So y'all, we're just going to graph it and see if this thing crosses that x-axis, okay? Well, y'all, look at that. It looks like it's crossing over, but it's in between a -1 and a -2. So y'all watch this. If I go to the table and I go to where the -1 was and the -2, it crossed over because it went from positive numbers to negative, but I don't have a zero here. So I don't have the exact zero yet. So guess what? Since my equation here has the 5 in the front of it, watch what I do, okay? So whatever number's in front of your polynomial, in front of your x3 term, watch what I do. So since that's a 5, y'all see right here where it says table set, I'm going to hit the blue button and the window button. Now I'll keep it at -2 to start. But you see down here where I'm blinking now, that little triangle table, That means what's the change in your table? So since I had a 5 in front, I'm going to make this a 1 divided by 5. I'm going to make it 1/5. If you have a 2 in the front, you're going to make a 1/2. If you have a 3 in the front, you're going to make a 1/3, okay? Because now I'm changing this table to go by fifths since I had a 5x to the third, okay? Now watch what that does for me when I go back to my table by hitting second graph. Look here, I started at -2, but y'all look right here. You got a 0 now at -1.4. So I know where my 0 is at -1.4. Now let me show you this. To fix your table back to a regular table, go to second window for your table. Now I'm still going to start mine at -2, but down here where it's got the 0.2, I'm going to change that back to a 1. Now when I go back to my table, by hitting second graph, it's back to the regular numbers, okay? So the trick is when you set your table, start at a whole number here, like a negative number or a positive, and then change the triangle table to a 1. So triangles in math means, we call that delta, but it means the change in something, okay? Ask my calculator one more thing. Let me ask it what that -1.4 is in fraction form. So -1.4, I'm going to turn it into a fraction by hitting math and enter. That equals a -7/5. So -7/5 is the first number I'm going to try with my synthetic division. Which means -7/5 is a rational zero because it looks like a fraction. Okay? Rational zeros are any number that I can make look like a fraction. In any regular number, you just put a 1 under it, it looks like a fraction. It's any number other than imaginary and radical, okay? All right, y'all. So since this is a 0, we better get a 0 remainder. So we're going to bring down our 5. So y'all, what is 5 times -7/5 equal? So if y'all multiply that, what would that give me? A -7/5 times 5. All right, y'all. So here we go. -7/5 times 5. Remember, you can put the 5 over a 1 if you want to. But y'all, them 5s cancel. And -7 over 1, this gives me a -7. And y'all remember, y'all got that calculator. So what I have, -7 divided by 5 times 5 equaled -7, okay? So y'all remember, y'all got that calculator. All right, 7 and -7 give me 0. 0 times -7/5 is 0. 245 plus 0 is 245. So what I need to know now is, what is 245 times -7/5 give me? All right, so a -7 divided by 5 times 245. Well, I know what it better give us. And y'all look at that. -343. That's what I needed right there. So that gave us a -343 added to 343 gives me an answer of 0. So -7/5 is my first 0. So now, remember, this now is a 5x squared plus 0x's plus 245. I'm going to set that equal to 0. All right, y'all, so let's hear. X squared term in a number. Let's move the number over here. So I'm going to subtract 245. And y'all look at that. I get a 5x squared equals a negative 245. So y'all, I'm going to do one more thing before I take square roots. So what would y'all do to that before you took square roots? All right, so we're going to divide. Good job. Yeah, because I don't like that 5 there. So let's divide by the 5. So y'all, that gives me my x squared. Woo, look at that. That's going to equal a negative 49. So now, square root both sides. So the square root of x squared is the x. That's going to equal a plus or minus. So y'all, here's the question of the day. What is the square root of a negative 49? So 7i, good job. So we get a plus or minus 7i. So when you negative under that radical, you will get imaginary answers. So y'all, the negative 7/5 is a rational zero. The 7i, negative 7i are other zeros. So for this one, you would choose B. There is only one rational zero, blank, and the other zeros are blank. So the only rational zero we got was that negative 7/5 up here. And then the other zeros would be the 7i, negative 7i. Okay. Then for part B, they wanted what? Linear factors. Now, this one's a little trickier than the last one, and I'll show you why. So first, that's a negative 7/5. So this will become x plus 7/5. 7i, this will become x minus 7i. Negative 7i, this will become x plus 7i. Now, y'all, here's the only thing. When you end up with a fraction like this, since I got a denominator on this fraction, I also have to put that denominator in the front. So whatever your denominator is, you'll also have to put that number in the front. Because if you multiply it through, you get 5x, and then these 5 would cancel, making that a 7. So if you got a fraction, and you will on this one, whatever your denominator is, you have to put that in the front of the linear factors, okay? Now, I don't know why MathLab does it, but whoever wrote the book, that's how they answer them. Me personally, I would probably just do the x plus 7/5, x minus 7i, x plus 7i. But we got to do it the way MathLab does to get credit on it. So when you got a fraction, that denominator goes to the front. All right, y'all. So let me make sure I got everybody logged in real quick. So I'm going to start my share on that. That way I can see everybody. So and Wells, Wilson. All right, I got everybody. Um, so y'all, any questions? All right, so y'all play with that foiling tonight. Y'all got a lot of foiling and a little bit of synthetic division to do. Tomorrow we get into rational expressions, and then Monday we will finish out our chapter 8 stuff, okay? So, no, I'm not seeing any questions on here. And I've got everybody marked in. So y'all, I will let y'all go, and I will see y'all tomorrow at 10 o'clock. All right, y'all have a good day, and I'll see y'all later.